Hello students, welcome to Educate. Today we are going to start with the next chapter of 12th physics, electrostatic potential and capacitance. So in previous lecture we have seen how electric field is related to potential. So we are taking a quick recap of the same. Force is given by Q1 Q2 divided by 4 pi epsilon naught r square. If we divide force by charge, what do we get? F upon Q. Then 1 Q will be left. So Q upon, let's write it as Q0, Q upon 4 pi epsilon naught r square, which is electric field. Now, if this electric field is multiplied by radius, then what do you get? E multiplied by R is Q upon 4 pi epsilon naught R. What we get, that is potential. So here in this chapter, we will see what is the relation of potential with R, how it is related with capacitance and other things. So let's see. As you know, change in kinetic energy is equal to work done. Here also we will see that change in potential energy is also equal to work done. So, and with the help of potential energy, we will derive the relation for potential and other related terms. So let's see one by one. So if you remember the very basic thing, that potential difference or potential is equal to work done divided by charge. Work divided by charge, and the unit of potential is volt. This was basic definition that you have studied in 10th level, but at this level potential will be given by Q upon 4 pi epsilon naught R. And also keep in mind that potential takes into account the nature of charge. In case of electric field, what you have seen, if charge is positive, then field is away. If charge is negative, means this is for positive charge. And if charge is minus Q, then field will be toward it. Here, this is not the case. Here, if charge Q is negative, then potential will be minus Q upon 4 pi epsilon naught R. In case of electric field, we don't write negative sign, but here we have to write. If it is positive, it's okay. Q upon 4 pi epsilon naught R, that's okay. So that point you have to keep in mind. Also, you must have noticed that if there are two charges here, suppose plus Q and minus Q, and at midpoint, if we find electric field, so it can never be zero. It is not possible. It will be zero at a certain distance, either here or here somewhere. So that is different thing. But in case of if you evaluate here potential, so you will get at this value to be zero. At midpoint, the electric potential due to this charge and this charge will become zero. The reason is very simple, because VQ will be Q upon 4 pi epsilon naught. Suppose this distance is R by 2. So here this will become R by 2, and V minus Q will be equal to minus Q divided by 4 pi epsilon naught and then R by 2. If you find the sum, so VQ plus V minus Q, so you will get 0. So this point you have to keep in mind, because potential is a scalar quantity. Now, Potential can also be written as negative gradient of electric field. E, E equal to minus dV upon dr. We have studied earlier in basic level like E equal to Q upon 4 pi epsilon naught r square and V equal to Q upon 4 pi epsilon naught r. So how are they related? So what you observe, E is V upon r. So this is basic level, but in effect, E is equal to minus dV upon dr. Negative gradient of potential is electric field. It means in the direction of electric field, electric potential will decrease. So we will do some numericals from there. We will get electric field. Suppose we have its components like x, y, z, and then we differentiate it. So different components of electric field also we will get, and then we can write electric field. We will see some numericals based on this concept. But before that, let's proceed. So let's see this graph and what do we conclude. If you remember, the dependence of E on R is E proportional to 1 upon R square, and dependence of potential V proportional to 1 upon R. Which one decreases faster with R? Obviously E. Here the same thing, here one more thing you will notice, if R equal to 1, then E and V must have same value. So here that situation is also shown corresponding to this value. When R becomes 1, then magnitude of E and V becomes same. But if you observe the decrease of E graph, here this is E versus R graph. So here earlier its value was larger, it is decreasing sharply, and at this point you see that graph of E goes below the graph of V. Here this is graph of V at this point. So decrease of V is lesser than the decrease of E with respect to R. And the two will touch this axis, distance axis, at infinity, because this can't be 0 unless R equal to infinity, E will be 0 and V will be 0. So practically it is not possible. It will keep on decreasing, but it will not touch this axis. So this variation you have to remember, because generally this question is asked in your exam. Now we are going to see one numerical. I think it is visible. Calculate the potential at a point P due to charge of this located 9 centimeter away. As I told you that potential V is equal to Q upon 4 pi epsilon naught R. Here information is given. Q is given this much, and 1 upon 4 pi epsilon naught is 9 into 10 power 9, and distance is 9 centimeter. So here you will write 9 by 100 or 0.09, and then you can evaluate. The same is evaluated for you here, and this comes out to be 4 into 10 power 4 volt. That is okay. Now, hence, obtain the work done in bringing a charge from infinity to that point. So, see, work done, W equal to, as I told you, W upon Q equal to V. So, W will be V into Q. Right. Here distance is not involved. What distance charge has traveled to reach this point where this potential is given is not given. So it means here the second part, does the answer depend on the path along which charge is brought? No, not at all. So here to calculate work done, what you have to do, you have got potential here. So and charge is given, just multiply, you will get the answer, and that will be whole. Here it is given no work done will be path independent. Any arbitrary infinitesimal path can be resolved into two perpendicular displacements, one along R and another perpendicular to R. The work done corresponding to the latter will be 0. So here, what is meaning? Any arbitrary infinitesimal path can resolve into two perpendicular displacements. There will be two displacements. One will be sin theta component, another will be cos theta component. So here they are saying that the one which is perpendicular, that work done due to that will be 0 because cos 90 is 0. Now we are going to see what is potential due to an electric dipole. I think you know what is dipole. Let's recall it, and then we are going to derive very important relation, and that is considered to be a little tough for children, but I will try to make it as simple as possible. So here you are given a dipole. Dipole is like this. Here we assume that there is minus q charge, here there is plus q charge. Now we are taking point P here and we join from this point and from this point. And then we consider midpoint of dipole. This is dipole minus q plus q, and separation, as you know, this is 2a. So this will be a and this will also be a. Now what you have to do is okay, this is better. So as you have seen, this is dipole, this is midpoint. From here the point is somewhere here. This point we have joined, this is point P, and this is say plus q, and this is say minus q. And from midpoint also you have to join this point. So suppose this vector is r vector, this is say r1, this is say r2, this angle is say theta, right? I think you have understood the point. Here this distance is a, up to here this is a, because you know that dipole is made up of two charges with the separation 2a. So here there is positive charge, here there is negative charge, and this is the point where we have to find out the potential due to this dipole. So we have assumed that from here to here this distance is r1, and from here to here this distance is r2. Here we are going to apply the cosine formula. So let's write the expression for potential at P. So due to these two charges there will be potential. So formula, as you know, so V1 will be Q divided by 4 pi epsilon naught, and we take distance. Here distance is R1, and V2 will be minus Q. As I told you in the beginning that you have to consider the nature of the charge while calculating the potential, because it is a scalar quantity. So this will become 4 pi epsilon naught R2. So total potential, if you write, so that will be equal to V. So V total will be equal to Q upon 4 pi epsilon naught. You can take out. Then what is left? If you take Q upon 4 pi epsilon naught outside, 1 upon R1 minus 1 upon R2. Now, what is difficulty here? Here we have to determine what is the value of R1 in terms of R, and this angle, as you know, this is theta. So this angle is theta. Sorry, this angle is theta. So now for here this angle is acute and this angle will be obtuse. This will be 180 minus theta. So for the two angles we are going to apply cosine formula. So cosine formula says if there is triangle, so Suppose you are taking this angle, suppose this is angle A, side opposite to it is say A, and then this side, say this is angle B, side opposite to it is B, this is angle C, so side opposite to it is C. So cosine formula says if angle is acute and you are considering this angle, then you can write the square of this. So you will start from here. You will write a square equal to square of those two sides which are enclosing the angle. So angle A is enclosed by B and C. So you will write B square plus C square minus twice of BC and then cos of this angle, cos A. I think you have understood. Now suppose you want side B. So for this, what will you do? You will write B square equal to, you will take these two sides. So C square plus A square minus 2AC and then angle enclosed cos B. Similarly, suppose you want to get the value of side C. So you will write C square. Then you have to consider this angle in terms of these two. You will write so A square plus B square minus 2AB cos C. So this is valid when theta is acute. But if theta becomes obtuse, then in that case, here either you can replace cos A by 180 minus A, or very simple, you just remove minus sign, convert it into plus sign. I think you have understood. So here, what is situation in our question? Here what is happening? So when we get R1, theta is acute, so we can write R1 square equal to, in terms of these two sides, one side is this, another side is this. So we can write A square plus R square minus 2AR and angle enclosed by the two, that is theta. So cos theta. Similarly, if we take this R2, here angle is obtuse or 180 minus theta. So for that we write R2 square will be equal to A square and R square will be there, A square plus R square plus 2AR cos theta. You have seen the difference. So in case of R1, if angle is acute here, or angle is theta, and here angle cos theta is replaced by cos 180 minus theta, that is why there is negative sign, so negative has become positive. So you have understood. Here we have to take out R square common from these two equations. So what we can do, R1 square equal to, if we take R square common, so here it will become 1, and in every term you have to divide by R square. So what will be left? So let's write this here. So this is 1 plus this will become A square divided by R square minus twice of, you are dividing by R square. So 2A upon R cos theta. Up to here, any problem? No? Good. Here we will do certain approximation. We will assume that A is less than R. So A square upon R square is less than 1. So it is very small. So we can ignore it. If we ignore it, then what do we get? R1 square equal to R square 1 minus 2A upon R cos theta. Up to here, any problem? No. Keep in mind, you have to find out 1 upon R1. Here you have got R1 square. Now you have to invert it. So if you write 1 upon R1 square, then this will become 1 upon R square, and this term will take negative sign. 1 minus 2A upon R cos theta into minus 1. Is it okay? If it is okay, then we can proceed. Now, so we are here. I'm rewriting the expression r1 square equal to r square times, or before it was a square plus r square minus 2ar cos theta. What I have done, I have taken r square outside. So when r square is taken outside, so it becomes r1 square equal to, here in place of r square it will become 1. So let's write r square, then 1 plus a square by r square minus 2ar upon, so you are dividing by r square, so here 2a upon r will be left, 2a upon r cos theta will be left. And as I told you that you can make an assumption that this is negligibly small with respect to 1, so we can ignore it. So we get r1 square equal to r square times 1 minus 2a upon r times cos theta. But in our question we need 1 upon r1. So just do inversion. So 1 upon r1 square equal to 1 upon r square, and here you can write 1 minus 2a upon r cos theta whole power minus 1. Up to here I think there is no problem. Now you need 1 upon r. So what you do, just take square root. So this will become 1 upon r1 equal to 1 upon r, and here you are taking square root. So this will become 1 minus 2a upon r cos theta whole power minus half. I have taken half power from both the sides. Now what will happen? 1 upon r1 equal to 1 upon r times, do you know binomial theorem? Although I have not explained you, 1 plus x power minus n. Suppose it is possible for plus n also when x is less than 1. So here we write roughly equal to 1 minus nx. Also 1 plus x power n can be written as 1 plus nx. This is from binomial theorem. We will study about binomial theorem later on. So I am not introducing it today. If need be, I will tell you more about it. So here, if we apply the same concept, so this will become 1 plus x power n, 1 plus nx. So 1 by 2 will get multiplied here. So this will become 1 minus 2a upon r multiplied by minus half cos theta. 2 will cancel out, and you will be left with 1 upon r times here a cos theta upon r. 1 plus a cos theta upon r. So we are left with 1 upon r1 equal to 1 upon r into 1 plus a cos theta upon r. So one expression we have got. So we have got 1 upon r1 equal to 1 upon r times 1 plus a upon r cos theta. Now our next work is to find the value of 1 upon r2. As I told you, in case of r2, there is positive sign in RHS also. So we are going to analyze it also. So what happens? 1 upon, r2 square is r square times, before writing this, the equation by r square plus a square plus 2ar cos theta. And if we take r square common, so r2 square equal to r square common, 1 plus a square upon r square plus 2a upon r cos theta. Now our concern is to get inverse of it. So here we write 1 upon r2 square equal to 1 upon r square, and here this term can be neglected. So we will be left with 1 plus 2a upon r cos theta whole power minus 1. And we take square root. So 1 upon r2 will be 1 upon r times 1 plus 2a upon r, sorry, cos theta whole power minus half. Then we apply binomial theorem. As I told you, 1 plus x power n is roughly equal to 1 plus nx. For physics purpose, later on in mathematics we will go in detail. So here it becomes 1 upon r2 equal to 1 upon r times, if we apply this, so it will become 1 minus 1 by 2 into 2a cos theta divided by r. So 2 will cancel out and we are left with 1 upon r2 equal to 1 upon r times 1 minus a upon r cos theta. Here we can write it 1 upon r2 equal to 1 upon r 1 minus a upon r cos theta. So only the difference is that of negative sign. So we have got the values of 1 upon r1 and 1 upon r2. So our main purpose was to evaluate the values of 1 upon r1 and 1 upon r2 because potential V is given by the relation is q upon 4 pi epsilon naught times 1 upon r1 minus 1 upon r2. Now we can put the values of r1 and r2 as we have obtained. So 1 upon r1 we got 1 upon r, so it will become q upon 4 pi epsilon naught, and 1 upon r1 we got as 1 upon r into 1 plus a upon r cos theta, and 1 upon r2 we got minus 1 upon r 1 minus a upon r cos theta. Now if we open the bracket, what do we get? Q upon 4 pi epsilon naught, and 1 upon r also we can take out because it is present in both the terms. So 4 pi epsilon naught r here, then 1 plus a upon r cos theta minus 1 upon r is taken out already. So 1 plus a upon r cos theta. So 1 will cancel out. 2a cos theta upon r. So what we get? Q times 2a cos theta divided by 4 pi epsilon naught. 1r is already there. Here this r will become r square. And if you remember, q times 2a is p. So this will become p upon p cos theta divided by 4 pi epsilon naught r square. So this is a relation. Here if we want to introduce a unit vector, then that can also be done, and in that case here we can introduce unit vector. So in terms of dot product, if we want to write that is p dot r, so that can be done. So now we can say that v equal to what relation we have got? V equal to 2aq, or we have got p cos theta divided by 4 pi epsilon naught r square. So here the values are given. Here we can evaluate it. We can create the situations like whether the point lies on the axis, it lies at perpendicular point, or it is on the opposite side. So let's see the situation, so you will understand what can be the possibility. Suppose charge is here. So here they are saying if a point is, if theta equal to 0 degree, so dipole is suppose along this and point is along this. So theta will be 0 degree, then cos theta will become 1, then we will get maximum value if dipole is perpendicular, point is like this. So in that case what happens? So here, if theta is perpendicular means theta is 90 degree. Cos 90 becomes 0. So voltage will become 0, means potential will become 0. And if point is just opposite, means angle between dipole axis and the point at which potential is to be found is 180 degree. In that case, cos theta will become -1. So our answer will be, in that case, v equal to minus p divided by 4 pi epsilon naught r square. So that is why here it is given that for 0 degree or pi, it can be plus minus 1 part 4 pi epsilon naught p pi r square. So you have understood this concept. Now, if there are system of charges, means many charges are there, and we have to find out potential at any point, then what will you do? So it is very simple. Suppose this is point where potential is to be found, and there are many charges here, here, here. Suppose there is charge Q1, Q2, Q3, Q4. So potential Vp can be found by Q1 upon 4 pi epsilon naught R1. Suppose separation of first charge is R1. Similarly, Q2 upon 4 pi epsilon naught R2 plus Q3 upon 4 pi epsilon naught R3 and so on. Or you can take out 1 upon 4 pi epsilon naught and then Q1 upon R1 plus Q2 upon R2 and so on you can write. But keep in mind that charge must consider its sign, means you can't write if charge is negative and you are taking its magnitude only, then that would be wrong thing. Means sign of charge is important here. So you have understood the concept of potential, and you have understood the formula of basic formula for potential due to a point charge. Now on the basis of this concept, we are going to solve one question here. So question says two charges 3 into 10 power minus 8 and minus 2 into 10 power minus 8 are located 15 centimeter apart. So there are two charges. One is 3 into 10 to the power minus 8 coulomb. Another is minus 2 into 10 to the power minus 8 coulomb. And their separation is 15 centimeter. Now, at what point on the line joining the two charges, is the electric potential 0? Take the potential at infinity to be 0. Okay, so let's take any point here and we assume that at this point potential is 0. So let's calculate it. Suppose we take this x centimeter, this will be 15 minus x centimeter. Now Vp, which is 0, equal to potential due to this q upon 4 pi epsilon naught. So just take 3 into 10 power minus 8 upon, here don't write the value of 4 pi epsilon because it is equal to 0. So we will multiply by that to get 0. 4 pi epsilon naught, and separation is x into 10 power minus 2. Why? Reason very simple, it is in centimeter. And minus 2 into 10 power minus 8 divided by 4 pi epsilon naught into 15 minus x into 10 to the power minus 2. Up to here there is no problem. If you equate it to 0, it means you can shift it to other side. Then what will cancel? Here 4 pi epsilon naught will cancel, 10 power minus 8 will cancel, 10 power minus 2 will be cancelled. So you will be left with 3 upon x only, equal to 2 upon 15 minus x. Make cross multiplication. So 2x equal to 45 minus 3x. Take this to this side. So 5x equal to 45, x equal to how much? It will be 9 centimeters. So from here it is 9, from here it will be then 6, just opposite. So we have got the value of x. there will be another value also if we evaluate from there. So that is your work. You will consider why. And let's consider this question. Here, electric field lines are shown for two charges. One is positive and another is negative. And here there are certain questions that what is sign of potential at point P and Q, or at point A and V, etc. And after that you will consider the potential energy also. So let's analyze it one by one. So the first thing, in this case, if this is positive charge, so potential, we have to take the distance which is smaller. Here distance of P is smaller than distance of Q. It means potential at Vp will be greater than Vq, because potential is inversely proportional to distance. So here less distance means more potential and more distance means less potential. This is case of a positive charge, but in case of negative charge it will be just a reverse. So here in this case Va will be less than Vb. So this is how you can easily determine the sign of Vp minus Vq if you want to find out, or Vq minus Vp, whatever. Similarly, if you want to find out Va minus Vb or Vb minus Va, so accordingly you can answer. That is simple. So give the sign of potential energy, and now then you can find potential energy. So how will you decide? Here again same thing you have to do. Let's see some explanation that is given. A small negative charge will be attracted towards positive charge. The negative charge moves from higher potential to lower potential energy. Therefore, the sign of potential energy difference of a small negative charge between Q and P is positive. Similarly, PE at A will be PE at B. This is case of second one. Here our question is give the sign of potential energy difference of small negative charge between the point Q and P and A and P. So in case of Q and P, what you have observed, Q is further from positive charge than P. It means at P potential is higher as compared to point Q. So here in moving a small positive charge from Q to P, from lower potential to higher potential, work has to be done by an external agency against the electric field. Therefore, work done by the field is negative. And here give the sign of the work done by the external agency in moving a small negative charge from B to A. And in case of negative charge, here we are talking about this is negative charge. So what happens here? Potential at this point is less as compared to this point. So here just opposite is happening. So that is why in this case, in moving a small negative charge from B to A, work has to be done by the external agency. It is positive. And here in this case, work has to be done by an external agency against the electric field. In previous case, since potential was increasing, so here work done was positive, but here potential is, in previous case what was happening, from Q to P potential was increasing. Here from B to A, what is happening? Potential is, in this case from B to A, potential is decreasing, just opposite. Once again you can understand it. If you move from Q to P, so what is happening? At point P potential is higher than at point Q. So here your movement is from lower to higher potential. Here what is happening? From point B to A you are moving, and because of negative charge, here potential will be higher, here potential will be lower. So you are moving from higher to lower in this case. So in this case work done will be positive, whereas in this case work done will be negative. So that thing is explained here. And does the kinetic energy of a small negative charge increase or decrease in going from B to A? So it is very obvious. Here if you are you are considering motion from here to here, and you know that if at this point potential is higher, say this is 5 volt, this is say 4 volt. What does this mean? Here there is one positive charge. We imagine that positive charge is here. Correct? Because of which this point is closer to this positive charge, that is why here there is 5 volt. This point is little further, that is why it is 4 volt. Now what they are saying, does the kinetic energy of small negative charge increase or decrease in going from B to A? So suppose there is a negative charge here, minus q. If it moves in this direction, so what happens? Its velocity will increase or decrease. Since it is negative charge, so there will be a force of attraction toward this positive charge, which is imaginary here. So its velocity will decrease if you move to that direction. So definitely what will happen? Its kinetic energy will decrease. And is there any other point that I left? So here the first one was, let's reanalyze. Give the sign of potential difference. As I told you, closer to positive charge, potential will be higher, and here closer to negative charge, potential will be lower. So this is one concept. Second, give the sign of the potential energy of a small negative charge between the point Q and P. Here this question can be analyzed other way around also, because if you consider the concept of potential energy, so what is that? Suppose you are given two charges. Here there is one charge. You can consider other way around. Potential energy is Q times V, right? And you have to make a comparison of potential energy at these 2 points. Here, as I told you, that potential at this point is higher. We can even say this is 5 volt, and at this point say it is 4 volt. Now suppose you have charge minus 2 take coulomb for making its calculation easier, and here also minus 2 coulomb. Now what is potential energy at this point? According to the formula, Q into V. So potential energy at P, so let's denote it as U. UP is equal to minus 10 volt, sorry, volt and coulomb, that is joule. So potential energy is at point P, it is minus 10 joule, and at point Q, UQ, it is minus 8 joule. And if you want to find out the difference between two, you can easily do UP minus UQ. If you do, it will be negative. If you do UQ minus UP, it will be positive. I think it is clear. Here also, let's calculate the potential energy. So for that, what we consider potential at this point. Closer the point to the negative charge, lesser will be the voltage. We imagine, suppose here voltage is 2 volt, here we imagine say 4 volt, right? So you have voltage at these points, and suppose you are taking one negative charge here, minus 2 microcoulomb, or just take coulomb for comparison. So this is 2 coulomb. Now find out the potential energy at 2 points. So if you find UA, so it will be how much? Minus 4 joule. And if you find UB, so it will be how much? Minus 8 joule. Now, if you want to find out difference, UA minus UB, so what do you get? UA minus UB will be positive. And if you find just reverse, UB minus UA, so it will be negative. So I think you have understood the concept very well. And this is all for today. We will continue with the next concept of potential, and that will be equipotential surfaces and other things. Thank you, Team Educate.